Okay, hello everyone. Guys, look at the practice test. This is from Wednesday. It's the day before Thanksgiving, okay? Okay, guys, number one, it talks about intervals. This goes back to the first things we talked about at the start of this trimester. Dot plots, box and whisker. This is a histogram. Interval means histogram, arranged like this. Guys, number two, the one that shows the middle or the median. The middle data point is the box and whisker plot, remember? In the middle of the box, that line in the middle of the box, that's the median, that's the point in the middle. Guys, number three, when the display has the tails are exactly the same on both sides. When the tails are the same on both sides, it's symmetric, okay? Equal on both sides. And when that happens, as the mean and the median stay almost the same. They stay right in the middle. The mean and the median staying the same. If data has a tail like this, it tails like this to the right, that means it skews toward the tail. It skews to the right. All right? It always skews toward the tail. Skews to the right. And what happens, guys, when there's a skew, when there's a tail, the tail pulls the mean away from the middle. The median stays in the middle, but the mean is pulled away. All right, so in this case, the mean is up here. It's larger than the median. All right, guys, find the mean of this data, round to the nearest hundredth, 2 decimal places. Want to put it in Desmos? All right, guys, I'm sorry, I already got it there. Here's the set of data. Calculate the mean. All right, I got 4.928. That's 4.93, then rounded off. Guys, you can do it in Desmos, put in your calculator. Again, you add up all those numbers and divide by how many numbers. That's the mean. The next question asks for the standard deviation. Now that you probably want to put in Desmos or use a calculator. Again, you find it down here on the keyboard, all right, under functions. Standard deviation, I'm using A because that's the set that I used right here. A equals, those are the numbers. I just copied and pasted them. All right, I got 1.579, so 1.58 rounded up, okay? All right, that's the mean, standard deviation. We just did those two. All right, guys, if something has a mean and a standard deviation, if we add 50 to all those, to every data element in the set, every single number, we add 50 to it, what happens? Well, the mean would go up by 50. All right, but the standard deviation stays the same because the standard deviation is a difference between two numbers. It's a range. All right, it's a measure of spread. The spread stays the same. You just add 50 to each number, all right? Guys, you're going to get a graph like this. All right, it's a normal distribution. The mean is right in the middle. Just come right down here, 18, right? It says it right there. Standard deviation is the difference, again, between the numbers. It's the distance. 3, right? 3. 24 to 27, 3. Or down here, 18 to 15, 3. 15 to 12, 3, okay? That's the standard deviation. What percent of data values are between 12 and 24? Well, here's 12 and 24. All right, add up those 4 numbers. Add up those 4 percentages. You end up at 95. 13, guys, a set of data, normal distribution. The mean is 38. It says it's normal, but the mean of 38. So 38 is the mean right here in the middle. Standard deviation is 6. So I added 6 to 38, got 44. I subtracted 6 from 38, got 32. What they're asking is what percent of this data falls within that interval, 32 to 44. All right, it's 34 on each side. Remember, it looks like this, guys. We're talking about one standard deviation from the mean. It's 68%. It's those two 34s. It's the two 34s added together, okay? All right, guys, this starts probability. Remember, probability is a fraction. The bottom number is all the total possible outcomes. That's all these numbers added together. Then I'm just going to select somebody. There's 30 different things I could select. All right, but of them, what's the probability I pick someone that plays badminton? Well, badminton is right there, 5. That's the top number, 5 over 30. You can simplify that, divide both by 5. All right, 15, again, asking for a probability, and probability is a fraction. All right, again, the bottom number is all the total possible outcomes. All right, so I counted all those up. 1, 2, 3, 4, 5, 6, 7, 8, all the way around. There's 12 possible wedges in here. If I spun this around, there's 12 possible outcomes. But how many of them are blue? That's what they're asking for here, the probability that's blue. 3 blues. All right, 1, 2, 3 blues. All right, divide both by 3 to simplify it. All right, guys, you got the same spinner, 12 on the bottom, but this one says yellow or red. Yellow or red. If it says or, it can be either one, so we add these two together. It could be yellow, those two, or it could be red, those 3 right there. So I add 2 plus 3, I get 5. All right, this one here, a class of students, 30 students. Looking for a probability. So it's a fraction, 30's on the bottom, that's the total, 30 students. They want to know, if we randomly picked a student, what's the probability they play volleyball or tennis? Either one, either one. They could play volleyball. It says here 4 play volleyball and 5 play tennis. However, 2 students play both. 2 students play both. So it's really 4 play volleyball like that and 5 play tennis like that, where 2 is in the middle. The number of students is really 7 that play volleyball or tennis. And you can think of it like this. It's 4 plus 9 minus 2. Oops, 4 plus 9, 4 plus 5 is 9. All right, because those 2 right there, we added them here with the 5. Guys, I'm sorry, let me do that again. How much time I got here? 4 plus 5 minus 2 equals 7. That's the 7 I put right there. Because I counted those 2 here and here. All right? No. All right, guys, the next one, we're making 2 selections. Guys, I'm going to have to go real quick here for the rest of these. 2 selections, 2 fractions multiplied together, simplify. Again, these are 2 selections. This one was 10 and 10 because we put it back in. This one, we don't replace it, so it's 10 and 9. Multiply them together, simplify that fraction. Okay, 2 independent events. Again, 2 fractions, multiply them together. The numerators and the denominators together. All right, question 21. Guys, the first one just asks for a total. The probability if I pick someone, I get an SUV. 240 is the bottom. Of the 240, 156 SUV. Simplify that. This one is conditional because there's a line right there. Of the female, not the total, of the female. So 180 females, the bottom. Of them, how many sports car? Right there, 45. Simplify that. All right, guys, 23. Again, it's intersect. A intersect B. What do they have in common? What do they have in common? All right, the Venn diagram. Guys, all the probability of all the numbers. How many numbers are there? I counted 12. This says the ones that are not in C. All right, not in C, the complement of C. So I just covered up C. 1, 2, 3, 4, 5, 6, 7 was on top. All right. Guys, you can draw a king of diamonds that would affect the second draw. You could draw a king of diamonds. That would affect the second draw. You're not replacing it. So those are dependent events, all right? Number 26 is the fundamental counting principle.